Hello, this is Ashish Dubey working as Assistant Professor in the Department of Civil Engineering, MIT, Mysore. In this session, I will be taking up the subject Introduction to Civil Engineering with the subject code BESCK 104A or 204A. In this subject, I will be taking up module number 3, which deals with the analysis of force system. What do you mean by force? Force is nothing but the pressure exerted by one body on another, but it is not that easy, especially when we want to study the effect of force system on a body. We need to understand certain idealizations made, or the concept of idealization is very much important. Why is it important? Because when we want to find a solution for a problem in engineering mechanics, we need to assume certain conditions, or whatever we call it in general as idealizations. When applying the laws and principles of mechanics to practical problems, a number of idealizations needs to be considered, or a number of idealizations are assumed to exist. Okay. So, here we need to have those conditions assumed, otherwise we will not be able to find a solution to the practical problems, or if we do not have certain idealizations, it will not be feasible to find the solution to a practical problem. Okay. So, that is why we need to understand the concept of idealization. See, as I said, idealization is required to study the effect of forces on a body. Okay. So, for that we need to understand the concept of idealizations or assumptions that we are going to make. Okay. So, the very first concept of idealization or the assumption is particle. What do you mean by particle? It is defined as an object which has no size but has mass and requires no space to occupy. So, this is the first idealization, particle, that is, it is defined as an object which has no size but has mass and requires no space to occupy. Please understand this point. Okay. So, if I give you an example, number 1, the movement of earth in the celestial sphere where earth is treated as a particle. Earth is treated as particle. The movement of earth in the celestial sphere wherein the earth is treated as a particle. So, now by looking at this example, try to understand the definition of particle here. If I give you one more example, an aeroplane can be considered as a particle for the description of flight path. So, what about this second idealization? Very much important, that is continuum. Continuum. So, what do you mean by this? The concept of continuum is purely theoretical or imaginary. The concept of continuum is purely theoretical or imaginary. It is said to be made up of infinite number of molecules packed in such a way that there is no gap in between the molecules, so that the property function remains same at all points. Okay. Now, let us see the next idealization. The next idealization is rigid body. Rigid body. What do you mean by rigid body? Again, the concept of rigid body is purely theoretical or imaginary. And now, coming to its definition, a rigid body is a body which does not undergo any alterations under the action of the forces or under the influence of various forces. That is, a rigid body is the one which does not change the position of the body or undergo no deformation under the action of external agency. So, if I consider a body and let me consider AB with a distance d in a rigid body. So, this will not change its position, or it will not go any deformation even after the application of loads, or this distance d will not be changing even after the application of loads. That is, this A to B distance d will not be altered. See, these F1, F2, F3, F4, F5 are the forces acting on the rigid body that is, if you look at the rigid body definition, the concept is purely theoretical or imaginary, and the rigid body is the one which does not change the position of the body or undergo no deformation under the action of external agency. External agency is nothing but the forces acting on a body. That is the concept of rigid body. So, in this subject we are going to assume all the bodies to be rigid, okay. Otherwise, it will be a deformable body. Here we are going to assume all the bodies to be rigid, okay. So, the next idealization will be point force. The next idealization is point force. What do you mean by point force? A point force is said to be acting at a point which does not occupy any space. A point force is said to be acting at a point which does not occupy any space. So, if you consider a man standing on a ladder, the area of contact which he makes with the ladder is nothing but the point force, okay. If I take an example of a ladder resting on a floor against a wall, and let the points be A and B, let us imagine there is a person standing at this particular point called C of weight say 600 Newton. Let that the distance from point A to point C be 3 meters. Now, in order to understand the point force, please observe this point. So, this is the point where the person is standing, but this point force is the point where the point of contact is made with respect to the ladder, that is taken as a point force. So, the weight of the person is said to be concentrated at this point C, okay. So, which is located at a distance of 3 meters from point A. So, there is a ladder resting against a wall and resting on the floor, and a person is standing at a distance of 3 meters from point A, and the weight of the person is 600 Newton. As you can see here, a person cannot apply his weight through a single point. There needs to be some area of contact. So, at point C, this weight of the person is said to be concentrated or making the contact. So, that point is called as the point of contact. Next, we shall take up the next idealization, which is force. Force may be defined as an agent which produces or tends to produce motion, destroy or tends to destroy motion. So, what is force? Force may be defined as an agent which produces or tends to produce motion or destroy or tend to destroy the motion. This is nothing but the force. So, if I consider a body and let me subject this to a force F. So, what happens if I apply this force F to the body? It tends to move, it tends to create a motion. Okay. So, this line where the force is being applied is called as the line of action. Okay. So, this is making the body to move, or it can even destroy the movement. If I apply the force opposite to it, it may even stop the body from moving. That is the definition of force. That is, force may be defined as an agent which produces or tends to produce motion or destroy or tends to destroy the motion, or it is also defined as the action exerted. It is also defined as the action exerted by one body upon another. So, force can also be defined as the action exerted by one body upon another. This is the definition of force, and these are all the 5 idealizations that has to be kept in mind before we try to understand the effect of force system on a body. Okay. So, let me list out the idealizations made. So, which are the basic idealizations? Starting from particle, continuum, rigid body, point force, and the last is force. So, these are the basic idealizations that we need to assume to arrive at a solution for a practical problem. So, why do we need the concept of idealization? Because we cannot apply the laws of engineering mechanics to find the solution to a practical problem. Why do we need to understand the concept of idealization? Because when we try to find a solution for a practical problem that involves the laws of engineering mechanics, we need to understand some idealizations, or we need to assume certain conditions. It is very important to make those idealizations to arrive at the solution for the practical problems, otherwise it will not be feasible to arrive at the solution for a practical problem. And hence, to study the effect of force on a body, we need to make all these idealizations or assumptions. Okay. So, after making these assumptions, next let us try to understand the characteristics of force. Okay. Next is we have characteristics of a force. So, in order to understand the effect of force on a body, we need to understand the characteristics of force system. So, we know that force is a vector quantity a force is completely specified only when its characteristics are specified. So, what are the characteristics of force? See, force is a vector quantity and this force can be specified only when you know its characteristics. So, what are the characteristics of a force system? That is, first one, magnitude, second one, point of application, third one, line of action, and the fourth one is direction. So, whenever you want to understand about a force system, you need to understand about these characteristics. Okay. So, what do you mean by magnitude, point of application, line of action, and the direction? It is the length of the force vector, magnitude. Next, point of application. So, at what point the force is acting? That is nothing but the point of application. Next, what is line of action? Line of action is defined with respect to its horizontality or verticality. So, line of action is nothing but whether the line is horizontal or vertical. I mean the force, if the force is horizontal or vertical. And then at last we have the direction. So, direction is either the force is acting upwards or downwards or towards right or left. That is the direction of the force. Either it may be acting upwards, downwards, towards right or towards left. So, these are the characteristics of a force system. Now, let us understand these characteristics with the help of an example. Okay. Let me consider a beam subjected to a force of 50 Newton at point C. Okay. So, as per the characteristics, if I write the characteristics of the force by referring to the figure, I can write the magnitude equals to 50 Newton, and second point is point of application. What do you mean by point of, at what point the force is acting? So, point of application So, what is the point of application? That means where is the force acting? It is acting at point C. So, this is point C. The next characteristic is line of action. So, what do you mean by line of action? Whether the force is acting vertical or horizontal. So, in this figure it is acting vertical. So, the line of action is vertical. And the last characteristic is the direction. So, direction, what do you want to look into? Whether it is upwards, downwards, right or left. Here it is acting downwards. So, this is how you write the characteristics of a force system, by understanding the characteristics of a force. Now, let me take one more example, which I had already written the diagram, that is a ladder resting against the wall. Okay. So, there let me try to write the same characteristics. So, this be example number 1, example number 2. So, this is a wall and this is a floor, and we have a ladder, and this point is A, point B. So, here it is said to be concentrated, point C, which is located at a distance of 3 meters from A. Now, if I write its characteristics, what is the magnitude of the force? The magnitude of the force is 600 Newton. See, this is the magnitude. The second characteristic is point of application. So, what is the point of application? Where is that force acting? It is acting at a point C, which is situated at a distance of 3 meters from point A. Three meters from point A. Here I had not mentioned any distance. Here I have mentioned the distance. So, how do you write this? So, point of application is at a distance of 3 meters from A, and the point of application is C. So, let me write this in bracket. So, where is point C located or situated? It is situated at a distance of 3 meters from A, as it is given in the figure. Next, third characteristic is line of action. So, line of action. So, this is nothing but a ladder. What do you mean by the line of action? Whether it is acting vertical or horizontal. So, again here it is acting vertical. And at last it is direction. So, direction, it is acting downwards. So, I hope you have understood the characteristics of a force system, how it is defined, and I have given 2 examples also. With the help of these examples, I hope you have understood the concept of the characteristics of a force system. Okay? So, initially we tried to understand about the basic idealizations, all the concept of idealizations, and next, after understanding what is a force, we try to understand the characteristics of a force system, how it is defined. Okay? Now, let me go to the next concept. System of forces. So, next is system of forces. When several forces act simultaneously on a body, they form a system of forces. It is when several forces act simultaneously on a body, they constitute a system of forces. Okay. If all the forces do not lie in a single plane, then they are said to be forming a force system in space. That is, when all the forces in a system do not lie in a single plane, they constitute a system of forces in space. So, please understand this point. If you understand this, then we shall move on to the classification of forces or force system, how the forces are classified. Okay. Classification of force systems or force system. So, classification of force system. Force is classified as coplanar force system, non-coplanar force system. Then it is further divided into concurrent force system and non-concurrent force system. In concurrent we have diverging, converging, both diverging and converging. Here in non-concurrent we have parallel and non-parallel. In parallel we have like parallel force system, unlike parallel force system. This is how the force system is classified. A force is classified mainly as coplanar and non-coplanar. Then if you observe the next classification, we have common classification of coplanar and non-coplanar. That is, we have coplanar concurrent force system, coplanar non-concurrent force system. In coplanar concurrent system, it is further divided into diverging, converging, both diverging and converging, and in non-concurrent force system, it is divided into parallel and non-parallel force system. In parallel, it is subdivided into like forces and unlike forces. Okay. Now, let me explain all the force systems one by one with separate figures, so that you will understand the concepts of coplanar, non-coplanar, concurrent, non-concurrent, diverging, converging, like parallel force, unlike parallel force, and non-parallel forces. Okay. This is in brief how you classify the force system. Okay. Coplanar force system. So, what do you mean by coplanar force system? Coplanar force system. What do you mean by coplanar force system? If the forces are lying in a single plane, then we can say it to be coplanar force system. If all the forces lie in a single plane, then we can call it as a coplanar force system. That is, if the forces forming a system lie in a single plane, then we call it as a coplanar force system. Okay. If the line of action of force system lie in a same plane, then the system is said to be coplanar. As you can see, the forces are acting in a single plane, then only we can call it as a coplanar force system. Next, non-coplanar. If the line of action of force systems or system do not lie in a single plane. Then the system is said to be non-coplanar. Here if you observe, the forces F1, F2, F3, F4 are acting in a single plane, and the forces F5, F6, F7, F8 are acting in another plane. If you consider both the planes together, then we can call it as a non-coplanar force system, but if you consider only one plane, then it is called as a coplanar force system. So, two coplanar force system is nothing but non-coplanar force system. If the forces are acting in a single plane, then it is called as a coplanar force system. That is, the line of action of the forces are lying in a single plane. Then it is called as a coplanar force system. Okay. So, here F1, F2, F3, F4 are acting in a single plane. Example for this, the forces or loads acting on a beam. So, the forces or the loads acting on a beam can be the best example for coplanar force system. And example for non-coplanar force system, the forces acting and reactions at the point of contact of the benches in a classroom. So, this is the best example for non-coplanar force system. Now, let us go to the next system, that is collinear force system. If I write F1, F2, F3, F4 and this is nothing but the line of action. If the forces are having a common line of action or the same line of action, then we can call it as a collinear force system. Okay. If the forces forming a system have common line of action, then it is collinear. Example for this is tug of war. So, you can treat the tug of war as the best example for collinear force system. Next force system, concurrent force system. So, what do you mean by concurrent force system? If the line of action of the force system passes through a common point or the point of occurrence, then it is said to be concurrent force system. So, if I write the example, so if you observe this figure, all the force are said to be having the same point of origin or occurrence. So, this is nothing but the common point of occurrence. That is, if you observe the definition, the line of action of the force system passes through the same common point, then we can call it as a concurrent force system. And if you observe these forces, they are converging at a point. Similarly, you can diverge the forces. So, this is converging, this is diverging, it has the same point of occurrence and it is diverging. And in few cases, we can have both diverging and converging forces. Both converging and diverging. So, this is nothing but the concurrent force system. It is nothing but it has common point of occurrence. The line of action of all the forces remains same point. Okay. So, the best example to understand concurrent force system is the rope and pulley system. Here you can easily understand the concept of concurrent force system with the help of rope and a pulley system. Okay. And next, coming to the next classification is non-concurrent force system. So, if you have understood the concurrent force system wherein the forces were having a common point of occurrence, here to define non-concurrent, if we say there is no common point of occurrence, then it is nothing but non-concurrent. So, if the line of action of the forces do not have a common point of occurrence, then we call it as a non-concurrent force system. So, if the line of action of the force system do not have common point of occurrence, then it is non-concurrent force system. Okay. This diagram helps you to understand about the non-concurrent force system, and example for this is the ladder resting against a wall and the forces which are acting on the ladder can be the best example for non-concurrent force system. And at last we have parallel and non-parallel. Force system. If the forces acting are parallel to each other, then only we can call it as a parallel force system. If the forces which are parallel are acting in the same direction, we call it as a like parallel force. If the forces are parallel and not acting in the same direction, then we call it as a unlike parallel force. And non-parallel force system, if the force systems forming are not parallel to each other, then we can call it as a non-parallel force system. So, in parallel, so I can give this as example F2, F3 as like parallel forces, this is example for unlike parallel forces and non-parallel. So, this is the example for non-parallel force system. I hope you have understood about the classification of the force system. In the coming sessions, we will be taking up the resolution and composition of forces and also solve the numericals on the same. Thank you.